Please welcome Joseph Donovan from OUCRU.
Did anyone pack a bag this morning? In goes your laptop, maybe some fruit for lunch. You squeeze in your rain poncho, but the bag cannot get any bigger. The fruit gets squashed. Now imagine your skull. It's hard, and just like your bag, it cannot get bigger when too many things are squashed inside. Inside your skull are just three things: brain, shown in blue, blood in red, and cerebrospinal fluid, or CSF, shown in yellow. CSF is continuously produced inside the skull, and it flows slowly out through a hole at the bottom. But sometimes that hole is blocked, and CSF builds up and squashes the brain. Sometimes a mass within the brain itself squashes both CSF and blood. Brain, blood, CSF. One gets bigger, the others must get smaller. Now, my thesis is about tuberculous meningitis, or TB meningitis. In TB meningitis, raised pressure within the skull is common and catastrophic for patients. Each year, there are 100,000 cases globally, and half of all patients die because of this raised pressure. But if we can detect this raised pressure and act to stop it, there is potential for enormous benefit. Now, there's a common saying that the eye is a window to the soul. Well, it turns out that the eye is actually a window to raised intracranial pressure measurement. Maybe not as poetic, but science doesn't always have to be beautiful. Now, in my PhD, I will perform ultrasound measurements of the optic nerve sheath. The optic nerve connects the eye to the brain. Around the nerve, but inside the sheath, is that same CSF that's being squashed by intracranial pressure. Under pressure, the sheath expands like a balloon, and if we put an ultrasound probe on the eye, we can measure that expansion. Optic nerve sheath ultrasound is cheap, safe, and easy to perform. But in TB meningitis, there's only one study of 20 scans performed to date. So far, I have performed more than 1,000 scans in 110 patients. I can then correlate sheath size with brain imaging and with clinical outcome. Do those patients with the largest sheaths have the worst brain imaging? Do they have the worst clinical outcomes? If we perform regular ultrasound measurements, say every 3 days, can we identify the pressure going up and act before it's too late? These are my research questions. So here we have optic nerve sheath ultrasound, potentially a simple solution for a complex problem in a high-pressure scenario. Thank you.